Hey everybody, my name is Tom Tullis. This is the Tomb of 3D Printed Horrors, and I'm finally getting around to doing an Ender-3 V2 build video. Now, before we get into it, I just want to say I've had a lot of people contact me, ask me what my thoughts are on this. Do I think it's worth about the 35 bucks or so that it costs more than the Ender-3 Pro? Yes, in short, yes, this is definitely worth the price that's being asked for it. Um, People are comparing this mistakenly to the Ender 3, and you really can't do that. This is more of an upgrade from the Ender 3 Pro, simply because the Ender 3 Pro had the upgraded Meanwell power supply, it had the upgraded 40 millimeter Y-axis extrusion rail, and it had a removable bed. This has all of those features. So when comparing prices, you really need to compare it to the Ender 3 Pro. Um, so I'm just looking at Amazon right now, and Ender 3 Pro is running about $236. On Creality's website, the Ender 3 V2 is running $269. So that's a $33 difference, and it's definitely worth $33 more. If nothing else, you're getting a 32-bit control board in the Ender 3 and Ender 3 Pro that was 8-bit. This also has the silent stepper motor drivers on it. So right there, that board is probably going to run you, for the 8-bit board, they're charging $40 or $45. And here you're getting a 32-bit version of it with silent drivers. So right off the bat, just that makes it worth the upgrade price alone. Um, in addition to that, you're getting a upgraded graphic user interface on the LCD menu. It's color now, which is nice. It's not a huge thing, but it is nice to have. Um, the things that really jump out at me on this that I really do like, aside from the 32-bit board, which means you're going to have faster processing when printing, um, cable management is much better. I no longer advise that you print drag chains for this. The cable management is fantastic. They've added belt tensioners for the X and Y belts, which is very, very nice. Yes, you could have gone to Thingiverse and printed them off and added them yourself, but this is really something that should come out of the box, and I think it's great that Creality added that. Creality has upgraded the extruder. It's still plastic, but they have added a tension adjuster screw. They have added a little brass collar that goes in, where if you are familiar with the older Ender 3 and Ender 3 Pro extruders, the filament would wear through the entry hole and create a kind of a slot or a V-shaped slot there, and it would cause drag. They have a collar, a metal collar that fits in there now that should eliminate that. Um, Additional thing, they've redesigned the hot end fan shroud housing a bit. Looks a little cleaner. I'm not a big fan that it now covers the bowden tube coupler, but that's not a huge deal. It's only one screw to remove it now to get access to that coupler, so that's not a big deal. They did redesign the fan duct for the cooling fan for the nozzle. It aims downward more now, so it's going to aim right at the tip of the nozzle. Before, it aimed a little bit high, so you didn't get all of the benefits of that fan. Now you do, so that's a really nice improvement. They added a storage drawer. Again, not huge, but it's a convenient thing to have. One of my favorite upgrades on this is they put these giant rubber feet on the bottom of it. Not those little tiny ones that were on the older Enders. These are huge, and they're going to be great for vibration dampening. So really nice job there, Creality. That's about it. They added a knob to the top of the extruder. That was something you could have printed on your own too, so not a big deal. But again, these are all just nice things that they've added. They've listened to customer feedback, what we wanted to see on this, what we thought should come standard, and they've put it on. The glass bed is very nice. It certainly eliminates any of the issues with the aluminum bed being warped or anything. You won't have that issue with this glass bed. The only complaints I have with this machine, they are still using the same bowden tube couplers that were on the earlier machines. They are still using the same springs for underneath the bed. Both of these will need to be replaced, in my opinion, and I'm going to run through that in this video. The coupler is like 50 cents. The springs are going to run you a couple dollars, but if you replace those two items, put maybe $3 or $4 into this machine, It's going to be a lot more reliable. The better coupler for the bowden tube will keep the bowden tube from slipping, and you won't have the leakage then inside of the hot end, which is a pain in the butt to clean out. And the upgraded springs, the light load compression springs that I recommend putting on, will keep your bed leveled for a lot longer period. You won't have to keep going back and adjust that leveling at all. The stronger compression springs will keep it in place for a lot longer period of time. So, one last thing. This has a bootloader on it. To upgrade the firmware, you simply download it from Creality, put it on the SD card, and plug the SD card in, then turn the machine on. It will automatically read it and upgrade the firmware. So that's just a huge improvement over what we had to deal with the earlier Ender-3 and Ender-3 Pro. Now, as I said, I did 3 upgrades on mine. 2 I think you should absolutely do. The first is the hot end coupler for the bowden tube. This will run you about 50 cents. You can buy a pack of them with some extra bowden tubes and such, and I'll link that in the video description, but it just screws in. It'll take you just a minute to replace, but it'll really make it a lot more reliable for you. The second thing is the light load compression springs. These are flat springs. They will work much better than the stock springs that come with the machine. Again, just spend a couple dollars on this. Replace these springs. You'll be much happier with your machine if you do. Just a quick run through on how to do that. You're going to unscrew the bed adjustment wheels, take those off. Then you're going to lift up on the screw that runs from the top of the print plate down through the screw into the adjustment wheel, and then swap out the spring. That screw ran through the middle of the spring. Now that the screw is out, you can pull the spring out and put the new light load compression springs in. Then you simply drop the screw back in place through the center of the spring and screw your wheel back on. Finally, this is not something you have to do. This has nothing to do with the reliability of the machine or anything that's going to make it print better, but this is just something I like to add. And this is a micro SD to full size SD adapter. I don't like working with the micro SDs. They're tiny. I'm always losing them. I like working with full size SD cards. This will run you about $6 on Amazon. I do have a link in the video description. But this just plugs in on the front of the machine, and I just use a piece of double-sided tape mounted on the front of the frame, and then I can use full-size SD cards. Again, this one isn't something you have to do. It's got nothing to do with reliability. It's just an ease of use issue. So, without further ado, let's get started on building the Ender-3 V2. To begin with, what we're going to do is remove the glass plate from the printer so that we don't accidentally damage it while building it, since we're going to be flipping this thing over quite a bit. There's 2 clips, one front and one back. What you're going to do is just gently take those off. If you can't get them, you're going to use either a wrench or one of the hex wrenches and just pry the edge up and away from the glass, and then it will rotate out. Get these 2 off. You can just store them in the storage drawer for the printer if you want. If you ever lose these, you can use binder clips just fine. Just get the small binder clips and that'll work. Take the glass bed off. Go ahead and you can take off the protective plastic at this point or do it later, but you definitely want to do it before you try printing on this. Set that aside. The new Enders are still using the same bad couplers as the old Enders. This is something you do want to replace. The coupler is what holds the bowden tube in place. If this slips, you're going to get leakage inside the hot end, and it's going to create a problem. It's going to be a mess to clean out, and you'll either have to replace it now or later. If you do it now, you'll save yourself a lot of hassle. The new fan shroud covers the coupler, whereas it was exposed on the older Enders, so you do have to remove the entire shroud to do this. It's only a single screw. It's this one right here between the 2 guide wheels, and just use your wrench to take that screw out. These couplers are cheap. They're like 50 cents. Just do this. It will save you so much hassle if you put a better coupler on at this point. If you look, there is a small hole there with a guide post, so you need to gently rock the wheel assembly up and towards that post a little bit so you don't break that off. and the fan shroud will just pull away then. And you can see the new setup for the fans with the V2 is very nice. They have a new duct for the nozzle cooling fan. It directs the air more towards the nozzle tip. The old ones directed it a little bit above that, so it wasn't quite as efficient. This also has the same hot end design as the original Ender-3, which works great. The only thing you got to do, as I said, is replace that pneumatic coupler for the bowden tube with a little bit better one. When doing this, make sure these two parts, those two screws, do not loosen. What we're going to do here is just take the wrench, start loosening the old coupler, take that out, and then you'll be able to depress that ring and pull that original coupler off. That's the coupler with the white ring top. Now the reason you're doing this is that bowden tube goes all the way through the coupler, down through the hot end, and touches the back of the nozzle. If there is a gap, molten plastic will fill that gap, and it causes drag on the filament as you're trying to feed it and retract it, and it will make your prints look worse. So what you're going to do is depress that white ring and just pull that coupler off the tube. And you're going to notice some indentations there on the tube where the coupler went in and attached. So what you're going to do when you put this tube back on is flip it around 180 degrees and put that rear end on the new coupler. Alright, we're going to screw the new coupler on. I'm going to do it with my fingers first, then use the wrench to tighten it down. Now I'm going to use a Sharpie marker to mark one face of it. Now that this is all the way in, I want to back it off one full turn. You're going to loosen it now, one turn. And that's what the mark is for, so you know when it's made one full 360 degree turn. What you're doing is this is going to allow you to get that bowden tube snugged up against the back of the nozzle nice and tight. So take your bowden tube, either take a fresh piece, or if you're using the one that you took off, remember to flip it over and use the end as it does not have the gouges in it from the original coupler, okay? So you're going to take that in, and you're going to insert it into the new coupler. This is the one with the black ring, or if you're using the stock one, it'll have a white ring, but you're going to force that all the way down until you feel it touch the back of the nozzle. Once you've done that, you're going to tighten it up. This is just going to make sure it snugs up against the back of that nozzle just fine and doesn't have a gap of any kind. Quick tip, put a zip tie under the movable collar on this coupler. That will keep it from accidentally depressing and allowing the bowden tube to slip. And then all you need to do is cut it off with a pair of wire cutters before you want to change the bowden tube. So once you've done this, you're going to check and make sure the wiring on the side of the hot end did not come loose, especially this wire on the right hand side under the Phillips head screw. You want to make sure it's still wrapped around under that screw. When putting the shroud back on, make sure that little post goes through the guide hole there at the halfway point on the left hand side and reapply your screw. Alright, now it's time to talk about eccentric nuts. If you look here on the side, you have a smooth post and on the right, a hexagon post. The hexagon is your eccentric nut. And the way eccentric nuts work is these nuts are off, the post through the center that holds the wheel is off center from the nut. So as you rotate the nut, instead of the wheel spinning in place, the wheel will make an orbit. And this allows you to tighten that wheel up against the rail or loosen it because it's moving in an elliptical fashion. This is a view of the eccentric nut taken off. And as you can see here, the post for the wheel is offset to the left. So as you turn the nut, the wheel is going to spin and make an orbit. And if you look at this illustration, here's a wheel. The eccentric nut is in yellow. The wheel is against the rail. And as you turn the eccentric nut, the wheel will make an orbit and actually move away from the rail. Once you get to the furthest point, it'll actually start moving closer to the rail if you keep turning in the same direction. So at this point, we need to adjust the eccentric nuts on the bed before we go any further. There are two eccentric nuts, and they are the ones that are hexagon shaped. If you're looking at two that are perfectly smooth posts, you're on the wrong side. Now, the way you adjust an eccentric nut is you're going to use your wrench and move it in very small increments. You should feel it loosen up. The ideal tightness for these wheels is enough that whatever it is that they're moving, in this case it's the bed, does not wobble. You don't have any jiggle to it. But you do not want the wheels so tight that you cannot spin them with 2 fingers with effort. They should not freely spin, that would be too loose. But you should be able to hold the bed in place and just barely be able to turn the wheels with 2 fingers without the bed moving. If you can do that and the bed does not wiggle, you've got your eccentric nuts perfect. All right, next up we're going to put the vertical extrusions on the printer. When you're facing the printer, I'm going to be referring to things as left and right. I mean your left and right. So in this case, we have a vertical extrusion with 2 widely spaced holes. This is going to go on your right hand side. These holes are holdovers from the older Ender-3 and do not apply to this printer, so it really doesn't matter. But the extrusion that goes on the left has 2 holes that are at the very end. Those holes go towards the bottom. They're going to be closest to the base of the printer. That's the one that you've got to be concerned how it goes on. Now, we're going to be adding a little bit of time here on the build to make sure these extrusions are not rotated, that they are straight, and they don't toe in or out at the tops. In my old video, I got a lot of complaints. People criticized me for this step, saying that if you just put the screws in tight, the whole frame's going to align properly. That would be correct if both pieces that you were inserting a screw into were tapped for the screw. But that's not the case with the Ender. You have one piece that is tapped and that the screw holds tight, and then you have another piece that is simply a smooth bore hole. That smooth bore hole is what gives you play in the screw and can have things off. So for all the people that messaged me, said I got it wrong in my original Ender video, please watch this part here where I'm going to demonstrate the play that the screw has. The extrusions are tapped. You can put a screw in there and it's going to be nice and tight. Here I'm just putting it in about 1/3 of the way and it's tight. You cannot move the screw without moving the extrusion. So for this, yes, putting the screw in, it's perfectly aligned. That's not the problem area. The problem is the holes in the base. They are simply smooth bore holes, and as you can see, the screw can wiggle freely in it. So there is a lot of play here when you sink these screws in for how the rails are going to align, and that's why we're going to add a little bit of time here and make sure we get it right. If you get these rails aligned correctly, you're going to get much better prints. So taking a little bit extra time at the build here is just going to save you a lot of frustration later. So make sure you got your rails correctly. The one that really matters is the one on the left with the 2 screw holes at the very end at the bottom. We're also going to use one of our cross extrusions to help get these aligned. We're going to make sure that they are parallel and don't rotate on their Z-axis all the way up. And it's just easy by running this up and down them once they're installed. Going to flip this over on its side. You can also do this on the foam that came with the printer if you want. I'm just going to put the rail up against the base, and using the M5x45 screws, we're going to put these in. You want to get them tight but not super tight. Now, 2 things to remember. You're putting a steel screw into an aluminum piece. If you put all of your weight into tightening this, you can strip the aluminum out, so don't do it. But in this case, we're going to purposely leave the screws just a hair loose. Just get the screws to where they touch, not to where they stop turning, but just to where they start to want to stop turning. You could probably still put a little weight into it, or not weight, but put a little force, and you could get them to go a little tighter. But you don't want to do that just yet. We want to make sure things are aligned before we really tighten those screws down good. So just get them on to where they start getting resistance turning, and we're going to flip it over and do the other side. So there, I'm just loosening on my hair. I got them a little too tight, and the rail's tight. It's not shifting on me, but it does give a little bit of room for getting those tightened up and adjusting that rail slightly. So again, we're going to repeat this for the opposite side. Flip this over. It's easier to do these if it's up in the air. That way it's not resting on the table and pushing the extrusion inward at the top. Just put your M4x45 or M5x45 screws in. Put the rail up. For the right hand side one, as I said, those holes through it are not applicable to this build. Those were originally for mounting the power supply unit on the early Enders, but they've put the power supply underneath the base now, so it's no longer, those two holes are no longer used. So go ahead and tighten this up, speed this up a little bit. All right, now I'm going to take that cross extrusion and hold it up against the rails tight. And what that is going to do is force them out of rotation so that they are aligned. And I'm going to go ahead and tighten up my screws at this point. This way I know they are not twisted on their Z-axis. And it's just a really simple way. If you got somebody there to help you, they can hold it while you're tightening it. But it's a very simple way to make sure you don't have rotation. And do the same thing for the other side. Now I should be able to take this extrusion and run it all the way up from the bottom to the top, and it should touch fully flush all the way up. If these are parallel to each other, it'll work perfect. If it doesn't, just go back in, readjust, loosen your screws a little bit, and readjust these until they are perfectly parallel to each other without any rotation. Now, next step. Next thing I got criticized for in my last video was using a plastic tape measure to measure the width of the vertical extrusions. Yes, plastic tape measures are imprecise for doing an exact measurement. You are correct. But we are not looking for a specific measurement here. We're not looking to see if something is exactly 10 inches across. What we are looking to do is see if the lower parts of the extrusions are the same width as the top ends of the extrusions. So it doesn't matter what the measurement is, we just simply want to know if they are equal. You could even use a piece of string for this and put a little tick mark on it with a Sharpie marker. We just want to know if we're getting the same width at the top and bottom, so it doesn't really matter what you use. Now, if you look at this graphic, if you measure the vertical extrusions and they are wider at the top than they are at the bottom, you're going to want to tighten the two screws that are closest to the center. And I've got these called out with little yellow arrows. What's happening is these screws are looser than the outer screws. And by tightening them, you're going to pull those vertical extrusions into alignment. If, when you measure this, it's towed in at the top is measuring a shorter distance than the bottom, you're going to tighten the outer screws down a little bit. And that'll help you get this into alignment and, again, get things working better for you once the thing is built. Next up, we are going to assemble the Xaxis assembly. This is probably the part that frustrates people the most, simply because of how tedious it is to get this thing in proper alignment. Now, if you saw my prior Ender-3 build video, this is the step where we used the spool holder mount to make sure that the crossbar was perfectly level with the base. The problem is that made tuning it a little bit slower because it had to be done after the assembly was inserted onto the Z-axis screw, which made taking it on and off a little slower, and it just added to the frustration. This new way of doing it is going to make it a lot simpler because we're going to be able to get this aligned without having the Z-axis screw on to hold it in place, so that gravity doesn't just pull it all the way down. Since in the old technique, we were only using a single piece to aid in alignment. In that case, it was the spool holder mount. In this one, what you're going to do is you're going to need two objects of identical height. In my case, I'm using 2 bottles of craft paint. Now, if you're doing this, make sure that the lids, they're brand new bottles, and that the lids are screwed on as tight as they will go. And yes, I did check this with a micrometer. They were both of equal height. As long as you screw those caps on tight, you'll be fine. But these fit perfectly on the extrusions on the left and right. And first thing, before we do this, we're going to put our extruder mount on the rail and get the wheels tuned. Get the eccentric nut wheel tuned. And what you want is you want the wheel to be tight enough that it doesn't wobble on the extrusion rail, but loose enough that it just free floats. and you can turn that wheel with 2 fingers and it won't move the extrusion, or it won't move the carriage, but you don't want any wobble in it. So get those wheels tuned right. And it's a lot easier to do it now before the assembly is built, and you're going to do it for the carriage that goes on the opposite side too. All right, if you take a look at the X-axis extrusion, you're going to notice that it has a couple of recessed larger holes. These are to fit screw heads into so that the assemblies you're putting on here fit flush. If you take a look at this, this is the gantry that goes on, or the carriage that goes on the right hand side. There's a screw behind that forward wheel, and it just goes in that recess. This is your extruder carriage. It mounts to the left hand side of it, and again you have a recess for the screw for the wheel that's closest to the center. You're going to put 2 screws in this to mount it. Now these screws, you're going to have to fit them up in there by hand like this, and then in the back of the carriage are 2 larger holes that you're going to insert your hex wrench through to tighten the screw, because you can't get a hex wrench in right up against it. You're going to have to insert it through the back like this. Now remember, these screws are steel screws going into aluminum. Don't put your full weight into it, you just want them tight. Now when doing this, you want to get the screw that's closest to the far left end tight, but this screw here that I'm doing that's closest to the center of the extrusion rail, you want a little loose. So tighten it and then back it off 1 turn. So this screw here closest to the end is super tight, the other one is loose. And what that will do is allow us to rotate this bar a little bit if we need to adjust it. So we're just going to slide it down. And what you want is it touching the tops of the 2 objects you've put on here. And that's going to help you get it aligned so it's parallel. Now mine is a little high on the right hand side, so I'm going to lift this up and try forcing that bar down. Since only 1 screw is tightened, it should rotate with a little force. Okay, forcing it down just a little bit, and it will rotate, and see how that does. And now it's perfect in alignment. So very, very gently now, without rotating it any further, you're going to guide this up and off the rail, and then you're going to go in and tighten those 2 retaining screws. Now remember, don't put your full weight into it. You can strip them out. But the first one you're going to tighten is the one that was loose. Get that tightened first, and then double check and make sure the other one didn't loosen up from rotating it. Now you've got that in perfect alignment. Next up, we're going to mount the Xaxis screw motor, and you want this coupler to make sure this is tight on that center post coming up out of the motor. You do not want this coupler lower and touching the motor. You want to make sure that post does not extend past the halfway point inside of the coupler, because you don't want it touching the Z-axis screw when we insert it. So you want it below that halfway line that you see there. We're going to mount these with, see, those are M4 by 18 screws. Get that on, and you're going to have to readjust these once the, get them tight for now, but you're going to readjust these once the screw is on if it's out of alignment. The screw is inside that large, or that long black plastic sleeve, but you're going to insert the screw into the coupler and then tighten that top nut on the coupler, or that top screw. One thing you're going to have to look for later is getting this in proper alignment. And if you look at this graphic here, the screw should not go all the way into the coupler and be touching the top shaft of the motor. You're going to want to hold it up a little bit so there's a gap when you're tightening that screw. You don't want it touching the top of that shaft that comes out of the motor. Once it's on, you need to look at the top vertical extrusion to make sure it looks fairly centered. It doesn't have to be dead on, but it should be fairly close. And if it's not, you're going to readjust the screws on the motor mount until it is. All right, next up, we're going to put the timing belt on the X-axis assembly. The first thing you're going to do is you'll notice it has these small brass crimped ends. Those are what's going to lock it in on the bottom. Those will go on the bottom of the extrusion. So Insert this through the X motor assembly. You'll notice on the end of the X motor is a pulley that has teeth on it. You're going to want these wrapped around and centered on that pulley when you're done. You don't want it wrapped up around the edge or anything like that, otherwise your printer's not going to work correctly. Pull this across the top of the rail so that it's down in that trench, and then you're going to slide on your extruder carriage. Before doing this, test fit your carriage and make sure the eccentric nut is properly tensioned, just like you've done on the others. You know what to do, 2 fingers tight, but can still spin it in place. Now, at the bottom of the extruder carriage are a mount with 2 slots. That's what the ends of this belt are going to slide in. Slide them to the back of the slots so they don't work out easily, but that's what it should look like. You can use a hex wrench to put them back in. Next up, we are going to have to put the belt tensioner on, and this is what it looks like. You will have an open slot at the top of the tensioner and to the rear. Now, when you take the inside actual pulley out, it only will fit in the same way it came out. You can't rotate it 180 degrees, so just pay attention to which way you pulled it out. Make sure the top of it is facing the top of the extrusion. Otherwise, your assembly isn't going to go on correctly. So I went back, loosened my belt at one end so I can wrap it through the pulley, and then I'll go back in and reattach it to the bottom of the extruder carriage plate. Just put it back in that slot. All right, next we're going to add the wheel carriage for the right-hand side of the X-axis assembly. This has a protrusion for one of the wheels sticking out that's going to fit in that recess on the X-axis rail. So you're going to go ahead and put your screws on at this point. These are M4 by 16 screws. You're going to go in, tighten those down. Now you're going to slide on the cover for the belt tensioner and put the tensioner wheel back on to hold it in place. Okay, on the front you have a countersunk hole for a screw. That is going to be your M4 by 14. This screw is found in the bag with the tensioner assembly. On the rear, you're going to use your M4 by 16 that's remaining and screw that in. Make sure you do the front screw first. One of the things I found doing this is this rear screw, the M4 by 16, does not go in all of the way. It's about 1 millimeter, or maybe not quite 2 millimeters up from the from being flush. And the only thing I can think of is it's a little too long and hitting the other side of the screw, the M4 by 14 that goes in the front. But if you put that countersunk screw in first and make it tight, it's okay. The tensioner is not going to shift on you. If you want, you could put a washer on that rear screw and make it even tighter, but it should be okay as it is. Now this is what your finished X carriage assembly should look like. You can go ahead and insert your bowden tube into the extruder as shown there. As I said, make sure that front screw, the countersunk screw on the tensioner, is the one that went in first and is fully sunk down in that hole. Next, we're going to add the Z-limit switch. This is using T-nuts. For those of you who don't know, T-nuts are designed to fit into these slot extrusions, these rails, and then they rotate into position once you start tightening them. If you look here at the top left corner and bottom right, the edges are rounded off. What that rounding off does is allow them to rotate 90 degrees once they're in the slot and fit perfectly, and then because the other corners are at 90-degree angles, they won't rotate any further. So get them in, start rotating them, and they will go into place. You do want the screws loosened as much as they can be loosened and still hold on to that nut when you first put them in. That way the nut can go all the way down into the slot in the rail. And just tighten these up. There is a small little tab on the bottom of the limit switch mount. You want that, for me, because we're using a glass plate, that tab should be about a wrench width above the bottom extrusion, the flat extrusion that makes the base. You don't want that tab flush with the top of that extrusion. You want it raised up a little bit. and that seemed to work good for my glass mount. That tab was originally designed for when the Enders were using a sticker for the bed, and it wasn't as thick as the glass. So raise that up a bit and you should be good. We'll go over all that in my bed leveling video that I will link at the end of this video. Now, put your glass back on. Get those compression clips back out. Put those on. Just one on the front, one on the back. If they don't hold your bed tight enough and get movement with it, just use small binder clips. Those fit on the front and back just fine. Get the small ones and they'll work great. All right, we're going to add the mount for the LCD panel now. That just attaches with 3 T-nuts on the side. Then you're going to go in and plug in your display mount. There's only one plug, unlike the old Ender-3 that had 3 sockets. You had to make sure you got it in the right one. That just slides onto the mount as shown. All right, we're going to mount the top cross extrusion on. This is going to use M5 by 25 screws. Get those tied in nice and tight. There's 2 small plastic end caps that come with this. You'll get those added on. They don't have to be on, but they just make it look a little nicer. Once that's done, we're going to go ahead and put the spool mount on, and that's just using 2 T-nuts. Make sure those screws are loosened all the way down but still holding the nuts, and then you insert them into the slot and then just tighten them up. Next comes wiring. A little bit less wiring to do on this one, simply because we don't have the JST connector in the back for the power supply. The motor connectors are thinner and wider than the limit switch connectors. So these are all labeled. They'll have a little yellow tag. The E is for extruder, so that one's we're going to attach first. This goes on the side. The next one should say X, and it does. So we're going to attach that to the bottom of the X-axis motor here. And then once that's on, the last one remaining will be for the X-axis limit switch. That'll be the shorter plug. And that's going to insert into the side of this housing here and just plug in, and there's a shot of it in place. Once that is done, you'll have one remaining set of wires here. That is for the Z-axis motor. Make sure that's what the tag says. Plug that into the rear side of the motor, as you see here. And then the Z-axis limit switch is the only thing remaining. So that'll plug into the bottom of that. Once you've done that, all of your wiring is done. On the back, we need to set the voltage. If you're in the United States, you want to set to 115. This little red switch slides to the left and right. You do not want it on 230. If you are in Europe, you want it on 230 because 115 will have very bad results for you. If you're in the US and are on 230, not much is going to happen. Your machine won't work. But if you get it wrong in a place that you're supposed to use 230, it will be bad. So if you're in the US, make sure it's on 115 as I'm showing here. All right, last step. We're going to see if this thing works or not. You're going to add the power cable to the back, plug that in. You're going to turn the power switch on the rear of the unit on, and you should see on the LCD menu the Creality logo, and it should power up. Go to Prepare, scroll down to Auto Home, and click the selector knob, and it should home in on all 3 axes. What it's doing is it's moving until it hits all 3 limit switches, one for the X, one for the Y, and one for the Z. And if it has done this, you have successfully built your Creality Ender-3 V2. Congratulations. At the top is a link for the next step, which is leveling your bed. I'm doing that as a separate video because people go back and refer to that a lot, and they don't want to have to scroll through the build video to get to it. So please check that out for how to properly level and get your printer running. Thank you for watching. Please click that subscribe button in the bottom right hand corner. Thank you.